So these first couple things that I'm going to write up on the board, you actually don't need to write down in your notes. I want to review just a couple things to kind of get your brains working in the right direction, especially since we just came back from spring break, right? So I don't know about you, but this was the first morning I actually set my alarm in the last week to get up. Yes. So that was a little bit of a shock this morning when it went off. Okay, so raise your hand if you can come up and solve this problem. Z plus 3 equals 0. Raise your hand if you can come up and solve that one for me. Kyle, go ahead. Z plus 3 equals 0. I want to solve for Z. Okay, Kyle, hold on just 1 second. How did you get negative 3? What did you do?
I subtracted 3 from 0, just do the opposite.
Okay, so you knew that since we were adding 3 on this side, we needed to subtract 3, right?
Yes.
Okay. And that's pretty, most of you can probably do that in your, that's more of like a mental math problem, right? Okay. So what about this one? What if I give you 3x plus 4 equals 0? This one's a little bit more complicated. Raise your hand if you can come up and solve this one for me. Do you want to give it a try, Kendra? Okay, come on. Are you sure? Okay. Yeah. Uh-huh. Yeah. What do you think? And then what are you doing? Yep. And then you have to do something. Come on. Come on. Yep. So the first thing that you're going to do is do what?
Subtract 4 because you're adding 4.
Exactly. So let's go ahead and do that. What would that look like?
Or would it be minus 4? We have 3x. 3x? Okay.
Yep, it's okay. Leave it like that, and then put equals, and then you can do negative 4. Right? And then these would cross out. Right? Okay, so then you have 3x equals negative 4. How do I get the x by itself?
You divide by 3.
Exactly. So you can do that, and then x equals what? Let's write our final answer.
Just write negative 4 over 3.
Yep.
Yeah.
Okay. Good job. All right. So that one had a couple more steps in it. Some of you may have been able to do that one as mental math. A lot of us, like me, need scratch work in order to be able to solve those. Okay. What if I give you this one? C squared equals 25. Raise your hand if you can tell me how I'm going to solve this one.
You would divide. Wait, no. I know the answer is.
Okay, so come up here. Come on. It's okay. What is the answer? Let's start with that. C equals what? Okay, that's the correct answer. So let's write that down and let's figure out how we got that answer.
So just write C.
Uh-huh. All right. What did you do to the 25 to get 5? Well, you divided by 5. How did you know to do that, though?
Oh, because that's multiplying by itself.
Mm-hmm.
Exactly, because this is a square, right? What's the opposite of a square sign or a square? What sign would be the opposite of a square? What do you think?
Oh, the square.
What about that? So how would I write this? What would I do to both of those to get my final answer? Uh-huh. Yeah. So you want to take the square root of this. Okay. Yeah. So you can draw that. Yeah, you can just draw it right over this one.
Okay.
Yeah. Exactly. And remember, whatever I do to this side, I have to do to that side. Exactly. So now if you type this in your calculator, right, that's where you get 5. And these cancel each other out. We can draw a line right through both of those, the 2 and the square root sign. Exactly. Okay. So yeah, a lot of times we know what the final answer is, right? We can kind of look at it and we can say, mental math, I know what C equals. but sometimes it's a little harder for us to explain what we're doing in order to get that final answer, right? All right. So any questions on the equations that we've looked at so far? Okay. So let's look at our lesson for today. We're going to solve by factoring. So I'm going to put a problem up on the board. Let's say we have an x squared, and this is where if you have not been taking notes yet, you probably want to get started. So x squared plus 3x plus 2. Okay. Now, if I told you just to factor this problem, you'd probably be able to factor the problem, right? Maybe with a little bit of help. It has been spring break, so you might need a couple of reminders of how to get started. But I'm not asking you just to factor this one out. I want you to solve it for me. I want you to tell me what x is. Okay, so let's look at a couple of things. First, we need to review a couple of terms that we learned way back at the beginning of factoring. Okay? Does anybody remember me mentioning, this was weeks and weeks ago, the term degrees?
Yes.
Okay, raise your hand if you can tell me what the degree of this problem is. What is my degree, Carl? 2. How did you know it was 2?
It was the highest, that one.
The highest exponent, right?
That one.
Okay. The highest, that one, the highest exponent. So what does my degrees tell me? I know the degrees, it's a second degree trinomial. What does my degrees tell me, Kyle?
Well, never mind. You just said trinomial.
Oh, okay. Yep, it's a second degree trinomial. Second degree, it tells me that I have 2 what to the problem? If I'm solving the problem, I have 2...
Exponents.
Hmm?
Never mind.
Okay, no, I do have 2 exponents. My highest exponent is a 2, Carl.
And number of possible solutions.
Yes, number of possible solutions. I have 2 solutions to this problem. So I have 2 possible answers for x. So what if my highest degree was 25? How many solutions would I have to that problem? Lucas?
25.
25. Okay, I'm not going to give you quite that hard of a one today. All right, so let's go ahead and look at how we're going to start solving this problem. The first thing when you're asked to solve any type of polynomial, you always want to start by setting your equation to 0. Okay? So we always want to set our equation to 0 first before we do anything else. All right. This is the point where we want to factor. So I have a trinomial. Raise your hand and tell me what's the first step in factoring a trinomial. Amanda?
You, I don't remember if it was like add or subtract or multiply, but like the first and the last number.
So I have a 1 and a 2. What am I going to do with those? I'm going to multiply, and that's going to give me what? Key number. Remember, then I want to find factors of that. So what factors of 2, Amanda, added together are going to give me 3? 1 and 2. Okay, and what am I going to do with those 2 factors?
Put them like where the 3 x's and
Yeah, I'm going to split them up, right?
Yes.
So then I'll have an x squared plus 1x plus 2x plus 2. What do I still need on the end of my problem? Equals 0. Okay, I don't want to forget about my 0 on here. So now I have my 4-term polynomial. What am I going to do with it now to keep factoring Lucas? I'm going to group them. So I'm going to do my invisible parentheses. And Connor, what would my GCF be of this first term?
X.
And what would I have left inside?
X plus 1.
X plus 1. And let's see, what would my GCF be of this second one? Lucas?
2.
2. And I'd have left inside an x plus 1. Don't forget, we want to set equal to 0. And what do we stop at this point and check for? Were you giving me my answer, Amanda?
Yeah.
What do I stop and check for at this point, Elizabeth?
That's a parentheses match.
That's right, and they do. So, Elizabeth, how would I write my factored answer?
X plus 2 in parentheses. And then x plus 1.
Okay. All right. So now I factored. Can I do anything else, or is my answer factored completely?
I'm pretty sure it's factored completely.
It's factored completely. Now, remember what Carl reminded us of. My highest exponent 2 tells me that's how many answers I can have for x. So I need x to give me 2 answers. How do you think I'm going to get 2 answers from what I have up there, Kyle?
One's gonna be positive, one's gonna be negative.
Okay.
Yes. You're thinking.
That's a good thought. How do you think I'm going to get my final answers from what I have up there?
You're gonna solve it. Like maybe for the first one you're gonna solve for 1, and the next one you're gonna solve for 1.
Okay, so how would I solve this? What would you do to start solving this?
I would do -2, and then for 1, and then do -1. Get my, yeah.
Yeah.
Okay,
They're so
can
close.
I just take it in the form that it's in right now and just subtract 2
Probably
from
not.
one of the sides? No, because they're in parentheses, right? And right now they're being multiplied together. So I can work this a couple different ways. Landon, you had your hand up. Did you have an idea of how to solve? What would you do?
If it's supposed to be zero, then the x has to be opposite, because if it's +2, then you have to -2 to get 0, and it's +1 to get -1.
Okay, so how would I set that up? What would it look like? How would you write that down on your paper?
-2, in parentheses, -2 plus 2, and in parentheses, -1 plus 1.
Okay, so that would still leave me with an x times an x, right, on this side. If I did that, it would still leave me with 2 x's. We're thinking in the right direction. Any other thoughts? You guys are so close. And it's a really easy thing, and it's something that when you look at it, you wouldn't think it's something that you're allowed to do. Lucas?
I'm just going to take a wild guess. Do the 2 parentheses count as answers?
As separate what?
Separate.
Everyone is so
Separate
close.
problems.
Yeah. There we go. Good.
Right, separate problems. We can't just start moving these around while they're still attached together, because this is a multiplication problem, right? So in order to solve, we're going to take our binomials, or however many terms we have, and we're going to separate them out into separate problems. Okay? And that would give both Landon and Kyle the answers that they knew in their heads, were the answers for x. We just need to know how to be able to write it out and solve it for when we have a more complicated problem. Yes?
That's why they need 2 answers.
Exactly.
For the 2 factors.
That's how you're going to get the 2 answers. So what would this first one be? X would equal what?
0.
-2. And on this one, x would equal -1. Okay, so let's go ahead and look at how we would write our answer. So we now have 2 different answers. I'm going to make the little squiggly brackets. Right, we've seen those. I'm going to do the little squiggly brackets, and I'm going to do -2, comma, -1 with a little squiggly bracket. Why do you think I'm not using regular parentheses?
Can I draw it? I think I drew it.
Yes, perfect. Why do you think I'm not using regular parentheses, Sean?
Because that's your answer.
Yeah, I want to show us my answer. If I used regular parentheses, what would it look like? It would look like a coordinate plane. It would look like an X and a Y point on a graph, right? And these aren't points on a graph. These are 2 X. I don't have an X and a Y. I just have 2 X's.
You're bumping buttons.
Okay, there we go. So I just have 2 X's. So I can't use a regular set of parentheses. I have to use squiggly lines. All right. Now, if we went and we plugged these back in, and let's just do a little bit of mental math real quick. If I plugged -2 back into my original answer, I'd have -2 squared, which is 4, plus 3 times -2 is a -6, plus a 2. If I added that up, that would equal 0. Same thing with the -1. If I plugged that back into both of the x's, my answer would equal 0. Okay? So you can always go back and double check your answers if you need to, if you think that maybe you don't have the right ones. Kyle?
So you only can solve for the ones that have a variable in it. You can't just for the 2. You can't make it 0.
Right, exactly.
Okay.
Okay. All right, any questions on this one before we look at a second example? All right, so let's go ahead and take a look at this one. What if, this one is going to look a little different in a couple ways. Okay, if I have 9z to the third plus 48z, and that's going to equal 42 negative 42z to the second. Okay, so right away looking at this, what was the first thing when we're asked to solve for the variable in a polynomial, what does my original equation have to look like? What was our first rule, Kyle?
First rule is the GCF.
Well, before I can look for a GCF, what does my problem have to look
I
like?
have all the variables on one side.
Everything has to be on one side, right? Because it has to be set equal to 0 in order for me to solve. So how am I going to get this negative 42z to the second to the other side?
Add it.
Yeah, I'm going to add 42z to the second to both sides. All right, and this is where another one of our definitions is going to come in. When I rewrite this problem, I need to rewrite it and make sure it's in what form? Lucas?
Standard.
Standard form. So 9z to the third plus 42z to the second plus 48z equals 0. My 0 is a little off. Okay. Now, I have it in standard form. Kyle, what did you notice about the problem?
When you
right
have a
away?
GCF, it's 3z.
I have a GCF. It is 3z. What am I going to have left inside, Kyle, once I factor my GCF out?
9z to the second. I mean 3z to the second.
3z to the second.
Plus 14z. Plus 16.
Okay.
Yeah.
So,
Robertson?
yes.
I think he has a calculator in his brain.
Who reminded me of my 0?
That would be me.
That would, okay, thank you, Lucas.
You're welcome.
So let's stop here for just a second. Okay. When I look at my original problem, what degree is this trinomial? It's a third degree. So Sean, how many answers am I going to have at the end? If it's a third degree trinomial, I'm going to have 3 answers at the end. Okay? So let's go ahead and finish factoring. I want you to do that on your own. So remember, you're factoring the trinomial that's inside your parentheses now. So let's finish factoring that. Yeah, so key number. Remember, what's the first thing that you're going to do with your trinomial?
You're going to find a key number.
You're going to find the key number. What is our key number for this one?
48.
48. So let's find 2 factors of 48 that add up together to equal 14. Who doesn't? Okay, so what did we find as our key numbers, Kyle? 6 and 8. 6 and 8 were the factors of our key number. Okay, so we found 6 and 8. So currently, if you were at these are going to be incurred answers left. I went 3, so I actually have
She was able to.
How that exists.
yeah. Okay, so let's see. Raise your hand if you still need another minute to finish factoring or finish finding the answer. Are you stuck for a while?
Did it just give you an error?
Okay, well, when you look at answers, what 3 things can I set equal to 0?
This right here is giving you an error, 3z, because you can't divide 0 by 3. Or would you?
Yeah, just think middle math. If this is what you have, so this is
3 divided by 0 would give you.
yeah, use middle math. 3 times 1.
No, it's from the
Times 0.
original problem.
Yeah, so see how it
The
works?
original problem is telling us.
Okay, yeah, I see.
Yeah, you're
I
right.
thought it was an error though, because
Yeah.
If it was the other way around.
Oh, okay.
Okay, so raise your hand if you can tell me from this point, what did we get as our factored answer? What did I get? I had 3z, and what were my 2 binomials, Kyle?
3z plus 8 and z plus 2.
Okay. All right. Equals 0. Well, I always want to remember that 0. So now that I'm at this point, remember we looked at our original problem was a 3rd degree. So how many answers do I want for z?
3.
I want 3. How am I going to get 3 answers? I need to set some things equal to 0. What am I going to set equal to 0 in this?
3z.
Yep, I'm going to have 3z equals 0. What else?
3z plus 8.
3z plus 8 equals 0.
And 3z, not 3z, z plus 2.
Z plus 2 equals 0. All right. Does everybody see how we got to that point? Where we're at, where we have 3 things set equal to 0. Lucas?
I've got a question.
Yeah.
On one of them it says 3z equals 0, but another one says 3z plus 8 equals 0. How is that going to work out?
Well, let's look at this. Let's go ahead and solve.
Oh, that's right.
Let me see if I can. I need to move this screen.
Are fractions okay for the answer?
Fractions are wonderful for the answer.
Okay.
If you have to go back and double check, you can leave them in fraction, or you can turn them into a decimal if they're easy
Okay.
to turn into a decimal. But yeah, fractions are perfectly fine. Okay. So let's look at that at this first one. 3z equals 0. How am I solving for z? Kyle?
0 divided by 3 would give you 0.
0 divided by 3, so z equals 0.
I thought it was an error at first.
Yeah, I know. It's easy to think that when you get an answer that equals 0. But remember, if I replaced 0 into each of these, right, my original problem, I would end up getting equals 0, because everything would be multiplied by 0. Let's see, raise your hand if you can tell me what I got as z for my second one. Yes.
I got -8/3.
Z equals -8/3, right? Because we had to subtract 8 and then divide by 3. And what about for my last one? That one was more of a mental math one, Sean?
-2.
Yeah, z equals -2. So on this one, what I'm going to do is I'm going to do my brackets, right? So I'm going to have 0. I'm going to have -8/3. And I'm going to have -2. So 0, -8/3, and -2. Yes, Zach. And we factor this. All right, so are there any questions on that example that we went over? That one was a little bit longer, right? Maybe. Okay, so any questions on this one? This one was a little bit more complicated than the first one because we had that GCF that we had to take out, right?
Yeah.
Okay, so any questions on that one before we move on to our next example?
I just don't get how Z can be three different things. It's still a Z. Why would you have three different
Because Z is a variable, it can be multiple different answers and you still get the same one.
It can be infinite.
All right. So let's look at our next one, and I think you're going to find this one maybe a little bit easier than the other ones. So let's see, 4C to the second minus 64. 4C to the second minus 64. Raise your hand if you remember what type of problem this is, Kyle.
You're going to split it in half, basically. You're just going to do the square roots of it.
Okay, and why can I do that? What's the criteria for being able to do that to a problem?
First, you need a variable which has by 2, so you can split it in half and make it by itself. And you also need another number that can be square rooted.
Okay, so both of my numbers have to be perfect squares, right? Things that can be perfect squares. And what has to be in the middle of these two numbers? A negative sign, right? I have to have a negative sign. I cannot have a positive sign and do a perfect square problem. So what's the first thing that I want to do to start solving this problem? If I ask you to solve, I want to set the problem to what first?
I guess standard problems.
What am I going to set it equal to first? 0. And then what are my two by variables going to be, Kyle?
2C plus 8 and
2C plus 8. 2C minus 8 equals 0. What is the next step that I'm going to take? Elizabeth, what am I going to do next? Once I get to this point, how do I finish solving? I'm going to separate them out. So I'm going to have 2C plus 8 equals 0 and 2C minus 8 equals 0. So what is my final answer for this one, Landon?
C equals -4 and C equals +4.
C equals -4. C equals +4. And so how would I write that? I would do -4, comma 4 in my little squiggly lines. So what do we notice about a perfect square problem? Did you have a question, Kyle?
Oh, no, I was going to say what you noticed.
Oh, what do we notice?
Basically, you just have to solve the first part, it's always the same answer, but opposite.
Exactly. If you have a perfect square problem like this, your answers are going to match each other. You're just going to have one negative, one positive. The other way that you may see that written, did you have a question, Kyle?
Yeah, you just put 4 and then the absolute value next to it.
Well, we don't want to write it as an absolute value problem. However, you can write it like this. And I know you've all seen where you have a positive sign on top of a negative sign with the number behind it. And that's what that's stating for you. It's stating that the answer can be either positive or negative. Okay? So either way you write it, whether you write it inside your squiggly brackets or whether you write it like this, either way would be correct. Okay? All right, so was this one a little bit faster, right? These perfect square problems are always the fastest. Okay, let's look at one more.
Maybe the hardest.
And, okay, so 3x squared plus 27. And I'm just going to go ahead and say equal to 0.
Okay.
No, you don't want to do decimals.
Oh my gosh, I
You can't have a negative on the inside though.
We can solve this a couple different ways.
two different ways.
We can solve this two different ways. Well, you're going to have two different answers, right? Because it is a second degree, so you know that you have two different answers. We can start the problem a couple different ways. So raise your hand if you think you know of a way to start the problem. How do you want to start the problem, Landon?
The greatest, since they're not perfect squares, you have to factor it, and the greatest common factor for both of them is 3.
Okay, so we can go ahead and pull out a GCF. And our GCF was 3. Where do we want to go from here? Because it's still not solved for x. Kyle, what do you think?
Okay, this is, you guys changed it drastically.
How did I change it drastically?
Okay, can I tell you what I did?
What did you do?
Okay, I minus 27, and then I actually I divided it by 3 to get 9, and I square rooted 9 to get 3.
Okay, so you started it the other way that we could have started it. Either way, you'll end up with the same answer. So check your final answer against what we get up here.
Okay.
Carl?
When you do that, like one triangle, everything is multiplied 3 and 9.
For like trying to find a key number? Well, that only works with trinomials. So let's take a look at this. This almost looks like a perfect square, right? But what's wrong with it? Why can't I treat it like a perfect square, Landon?
Because you only have, on one side you only have a variable, or it's positive too.
It's positive, right? It doesn't have a negative sign, so I can't treat it like that. So when we have a problem like this, I can't set the 3 equal to 0 because it's just a 3 by itself, right? And 3 equals 0 is not a true statement.
No.
Since it doesn't have a variable, I can't do anything with that, so we're just going to forget about our GCF on the outside. Then how can I rewrite the inside to help me start to solve the problem? Kyle?
Never mind, that doesn't work.
Okay. X squared plus 9 equals 0. Right? Just like we did with our other problems, I can take my binomial, I can set it equal to 0. So now let's go ahead and solve for
Oh,
x.
you can make it 2 different problems.
What's the first thing that I'm going to do to solve for x on this one?
Wait, what the 3? Yeah.
The 3 right now, because it doesn't have a variable with it, we pulled it out as our GCF, but we can't set it equal to 0, because if we try to do that, we would just have 3 equals 0. And is that a true statement? No. So we can't solve for the 3, so the 3 is just going to stay on the outside of our binomial. Okay? So we can only set what's inside the parentheses equal to 0. So what's the first thing we're going to do to solve for x, Carl?
You subtract the 9.
I'm going to subtract the 9 from both sides. So now I have an x squared equals negative 9. What am I going to do now? Kyle?
I would find the square root of 9, which is 3.
Okay, who has a calculator out? Okay, everybody that has your calculator, I want you to find the square root of negative 9 and tell me what it gives you in your calculator.
Error.
It gives you an error.
Yeah.
You cannot take the square root of a negative number, right? Because any number times itself, negative 3 times negative 3 is always going to be a positive. 3 times 3 is always going to be a positive. You can't have a negative square root. So if I can't solve the problem, what kind of problem is this, Landon? Prime is for trinomials. No solution. So this one is a no solution.
Is there a possible way we could recognize these before we did all of that work?
Yeah.
Wait, so it's a way I did
Well, once you set it up like this, and you realize, or even at this point, if you had started solving it like Kyle did, and you had subtracted 27 from both sides, you would have seen that you would have had to take a negative square root. Kyle?
Yes, the way I solved it too is supposed to be no solution too.
Exactly, because your answer should look like